Okay. So yesterday we learned how to find the antiderivative. And we've learned how to approximate the integral using area under the curve, like rectangles or trapezoids. But what if we want to find the exact integral of a function? And we will be able to do this algebraically eventually, but we're building up to that. Quiz tomorrow.
It was going to be
Like
today.
our anti-power rule?
On sums, Riemann sums. Sums and, what did we do? So we did Riemann sums, trapezoidal sums, maybe one antiderivative problem.
How did you remember that? You don't have it like written anywhere.
Did you notice that it was just randomly thrown out?
I know. I thought
That's
it was
why.
Are you talking about the topics I remembered, or?
No, just the fact you remember there was a quiz tomorrow.
Oh,
Because like normally you have to write it down or else you forget.
yeah. Well, that's why it happened randomly in the middle of another thought. Because I don't remember if I try, but if I'm not trying to remember, it'll come at random times.
Oh, so it's
There's a curve by
intercorrelate.
using geometric area formulas. So we've learned that integration is area under the curve. And we also learned if we accumulate that area and find area under the curve at certain points, we can make a function which is the antiderivative. So let's take one of our easiest ones. Let's make it 3 this time. So if we have f of x equals 3, then we have a straight horizontal line. And we said our goal is to find area under the curve. So when we say area under the curve, our top bound is the function. What is our bottom bound when we say area under the curve? X-axis. So this is definitely the top bound. Bottom bound. So if I just said right now, find the area, if I asked you to find the area under this curve, what's going to happen? Going to reach infinity because it keeps going forever. Okay, so Melinda is saying you have to have the, what do you think she means by that?
Interval.
Interval. You have to have an interval. You have to be able to know where do you start, where do you finish. We need an interval that tells us where should we start this, where should we finish. So we need, we call the first one A. It does not have to be on the right of the x-axis, just I picked a random spot. We usually call the end B. So if we have an interval then it limits and we only take one chunk of the area. So we could actually find the area right now. We know the height of our rectangle. What's the height of our rectangle? 3. What's the width of our rectangle?
B minus A.
B minus A. Remember, whenever we're trying to find distances, then we're usually going to do subtraction. Geometry, distances is all about subtracting the ending value minus the starting value. So I could say the area here is 3 times B minus A, area of that particular rectangle. So notation-wise, we need a way for the integral to tell us where should we start, where should we finish. So we learned our integral symbol yesterday. Okay, kind of the long shaped S.
I always thought it was an F until yesterday.
I don't even.
I don't know if it's technically a,
S.
like, yeah, it just looks like an
It
S.
looks like it. I
I
don't know
am
why
not
thought
sure
it
where
was
they
an
got
F.
the symbol from. So, then they had to give us a function that we're integrating.
Duncan. Did we know Duncan Duncan?
So we also need a place to start and a place to finish. So on our integral symbol, they tell us where to start on the bottom of the integral. This is the start, or we could call it the left bound.
Oh, that's what was 4.
And at the top tells us where to finish. This is the right bound. So it gives us our interval. We're going from A to B. So we could also write our interval, from A to B. That symbol itself, when we write numbers below and above, tells us an interval that we're working on. Now right now, if I just gave you any random function, say x cubed, yes, you could find the antiderivative. Yes, you would know it has a start and a finish. But right now, we don't know what to do past that. We wouldn't know how do we apply that start and that finish to this antiderivative. But if I gave you a function that is a geometric shape you know, we could find the area under that curve using geometry. And this is something they actually might ask you to do on the AP test, not just building up to something else. They might ask you to find the area under the curve because they like to give you piecewise functions that are made up of various geometric shapes. Sorry, I'm making sure this function will turn out into the geometric shape that I want it to be. So I guarantee this is a geometric shape we can find the area of. We're kind of limited. We only have 4 we can really find the area of. They're never going to ask you like about a hexagon or a pentagon. Okay. So this is definitely a geometric shape. What kind of geometric shape? What do we recognize this to be? It's written in a different form. If you don't know, let's plug it into our calculator and see what it comes up with. Let's go graph this. Everyone grab their calculator and graph this.
It's a circle.
I
It's a half.
It's 8/3.
No, it's a half. Because it only shows the positive end, not the negative.
Oh, sorry. That is not what I
Oh, I
wanted
was
to bring
like,
up.
she just threw me.
I wanted to bring up this. shape are you getting when you graph this? A half a circle. Why isn't this a full circle?
Because
You can't have square root of
But I could have put a negative out
That's
front.
true.
I could put a negative out front. Why would I only use this? Keep in mind we're using functions.
Because a full thing would not pass the line test.
A full circle would not pass the line test. A full circle is a relation. So I'm either going to use this or I could use a circle underneath. I could have put a negative out front, which will change what our final answer is. We'll see that in 1 second. So we have a circle. With a radius of what? Or a half circle. Radius of 2. So we know we're going -2 to 2. We go up to 2. So according to the integral that was given, what area are we trying to find? From 0 to 2.
So you go from bottom to top.
We go from left to right.
No,
0.
the notation.
Oh, yes, sorry. The notation, bottom is where we start, top is where we finish.
So that's what the
Yes.
numbers mean on the integrals.
Hmm?
They just mean that's how far you go.
Literally just means that's how far you go. Well, we could apply what's called the fundamental theorem of calculus, but we're not going to do that yet. We need these areas before I can do fundamental theorem of calculus properly. So, what am I really finding the area of geometrically? Quarter circle. So we know area of a circle. Area of a circle is,
R squared.
but it's only a quarter of a circle.
so it's 1/4.
You could put 1/4. I usually put divide by 4. Same thing. It's the exact same thing.
Exactly.
And what's our radius? 2.
Oh, that's so easy.
So pi times 2 squared over 4 is pi. That means now we know the integral from 0 to 2 of the square root of 4 minus x squared is pi. We know that integral now. We did it using geometry, but we still know that integral. So let's have you guys try one. Okay. So what is our integral? 16 is correct. Did everyone get 16? Okay. So we need a couple of things along with this concept. What if I asked, let's go to a new page. Do the integral from -2 to 2 this time of negative square root of 4 minus x squared.
Yeah, I remember that song. What? I don't know that
So
song.
now this time, what is my shape? Still a circle, but it's on the bottom. It's under the x-axis. So we consider area a little bit different when it's under the x-axis. Not a lot different, just a tiny bit different. That is not a very good circle, but pretend. if I'm finding this area, I could still, even though it's under the x-axis, we know where to start, we know where to finish. So I'm finding the area of a half circle. So pi r squared divided by 2 this time. So 2 pi this time. But when it's under the x-axis, for the integral, so area is always positive. But the concept of the integral being area under the curve, and really when we say under the curve, again we're talking about from the curve to the x-axis. If it's under the x-axis, we consider this a negative value. So instead of this whole integral equaling 2 pi, it equals negative 2 pi.
What if one is on the top and then the other part is on the bottom?
That's exactly where I'm leading to. Read my mind. Okay?
Have you been wearing a wig on this?
So, Evelyn has a very good question. What if part of it is on top and part of it is on the bottom? Let's try it out. So this time I am going, well, no, I'm not going to go there yet. So if we draw this line on that particular interval, this time it's not going to be limited to just the first quadrant. We're going to be first and third quadrant. So we have a line. Let me cheat. We're going from -3 to +7. So on mine, I'm going to make -3 here. 7 here. So, this time, I basically have 2 shapes. What 2 shapes do I have?
Triangles.
2 different triangles. We have one little triangle and one big triangle. Do we know how to find the area of the triangle? Yes. So we're going to find these areas separately. We're going to treat these as 2 separate geometric shapes. I'm going to find this area of the smaller triangle and
That
I'm
area.
going to color this area of the larger triangle. So you guys know how to do that. I want you guys to find each of these areas, keeping in mind that the one that's in blue will be a negative value. So find each area individually. What did you find for your area under the curve?
-4.5.
-4.5. Eliana, what did you find for your area above the curve? 24.5. So why would I add these together? I didn't hear what you said, sorry.
Is it because you're finding the area of all of it too?
Area of all of it is total area, which is adding stuff together. So, adding it all together, we have a net change of 20. So physics-wise again, that's saying first, because my negative was first I walked back 4.5 units. Then I walked forward 24.5 units. So from where I started to where I finished, that net change is 20. So not the total distance I traveled, just from where I started to where I finished gives me a total distance. Or sorry, a distance from start to finish, a net change. So some problems as well, we need to know some rules of integration. I could not think of the word rules for some reason. Rules of integration. So my first rule is what if I'm adding two functions together? It's a rule we've actually seen yesterday a little bit.
You can split them up.
You can split them up into two separate integrals. Now on differentiation, usually what I do is I let you kind of do that intuitively. With integration, we can't do that because on the AP test, there will be some problems where you literally have to split them into two. It'll say like 3f of x plus 2. And so you'll want to split them up because you can actually integrate 2 on its own, and they'll give you the information you need to integrate 3f of x, maybe area under the curve. So you can split it up into two separate integrals. So, second rule, what if I have a constant times my function? What can we do with that constant? We can basically take it out of the integral and integrate and multiply by the constant after. So c times the integral of a to b of f of x dx. What if I go from a to a? What if I start and finish in the exact same spot? What would our area under the curve be if we started and finished in the exact same spot? 0. There'd be nothing. You didn't move. There's no area to find. Okay, then the last one we need is what if they changed the order? What if instead of going from A to B, we go from B to A? So when we do A to B, A must be smaller than B to integrate. Right now we have B on the bottom, that's bigger than the finish. So somehow, we need to flip those. We want it to be from A to B and not from B to A. Well, when this happens, we get negative that value. And then something I forgot we should talk about because it's on the homework.
A to B, B to A, it's because negative.
If we started from A to B, and I want to flip that back to A, sorry, if I start from B to A, and I want to flip it back to A to B, we just put a negative out front.
You can switch the points.
You can switch the points as long as you change the sign of your integral.
So if it's already negative, it just becomes positive?
Yes, so if it was negative B to A, it would flip to positive A to B.
Figure this stuff out. Did they just test a whole bunch of points?
Couldn't they just make up stuff?
No. We could explain this one, like the other ones I can explain fairly easily. But this one, I think we need a little more information before I could explain it properly. We need the connection between this and the antiderivative before I can explain this. So, if you remind me when we get to the fundamental theorem of calculus, then I can explain this. Oh, sorry. You made me lose my train of thought.
Well, if it's a train, it shouldn't be too hard to find. We're putting it in a neat little box without a top or a bottom.
So this one we'll see a little bit on the homework. And what's the difference between putting the absolute value bars on the entire integral compared to just putting it on the inside?
On the inside, it could still be negative.
If there's a negative on the outside.
I have a question.
No.
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 Shouldn't the second absolute value be inside the d of x? Isn't the
That's a
d of
good
x
question.
like connected to the b of
Ben is
x?
correct. Winning. Well, Ben is winning.
Okay.
Okay, but still, it's all about order. Order of operations, basically. What should I do first on this one?
Solve it integral.
Take the integral first, then
Make everything positive.
make everything positive.
We should get some.
So you could still have negative values being added to positive values here when you integrate. So you integrate first.
Oh, you know what's funny? If you were to absolute value someone, you would make them into an optimist because everything they said would be positive.
Okay, on the next one, I want to make everything positive first. That means every area I have will be positive. Then I would add them all together. So this one we make every area positive. Then add them together. Let's do one last problem where we have a whole bunch of different shapes.
Oh wait. What's the right answer?
Only areas possible.
And they would have to specify that this is a quarter circle. So So I am telling you that as a quarter circle.
So if they didn't specify, then what would you assume?
If they didn't specify, you could not assume anything. We would not have enough information to solve this.
Not enough information.
Yep.
Okay.
So they will specify.
So hopefully they have a typo and they don't. Just not enough information, get 100% and ace the ACT. Eight is the what?
So I am specifying this as a quarter circle. It doesn't look super circular. Everything else is straight lines.
It looks just like the design before I turned it into a curve.
So I could ask you any integral on any interval. I could say, let's find the integral from 1 to 4. So what shapes would we have if we go from 1 to 4? This one would be only triangles. And we're actually going to have a negative answer. We'd find the area of the first triangle, 1/2 base times height. So base is 1, height is 1. So 1/2, 1 times 1, plus 1/2 base times height again. I should specify how far down this went. Let's say it goes down 4. So 1/2, 2 times 4. Oh, but what should I change about this? I forgot to do something with this. One is a negative. Which one should I have made negative instead of positive? The 2 times 4 one, so minus. So we would have 1/2 minus 4, which is negative 3.5. Or maybe I could get that circle involved. I could ask you the integral from 1 to negative 2. So we should notice something right off the bat with this one.
It's BA.
It's BA instead of AB, so how am I going to fix that?
Make it negative.
Make it negative. So negative, and the bounds don't change signs. The bounds don't change to a positive 2 and a negative 1. It just changes the entire integral to negative. So now I just look at my shapes again. We said we had a quarter circle here. What shape from 0 to 1? Trapezoid. So area of a quarter circle is pi r squared over 4. Since our radius is 2, it's pi. The next piece is also positive, so I would put plus. But since the entire thing is negative, I am putting that negative parentheses because the entire thing is negative. So pi plus 1/2 base 1 plus base 2. We went up 1 on one side, up 2 on the other, so 3 times height, which is 1. And the trapezoids are turned sideways. It's like when we did trapezoidal rule, we had to turn our trapezoid sideways. So overall, if I clean this up, I would get negative pi minus 1.5. If I distribute at negative, so I don't have parentheses anymore. So in the homework, I'm just going to give you one picture. You're going to be working with one picture only, with a whole bunch of different shapes. And then there's going to be a whole lot of different intervals that you're going to have to find the integral of.
Could you scroll back up?
Always let me know if I go too fast.
Oh, by the way, you went too fast.
Helps if you let me know during